Hey everyone, welcome back to Learn and Grow with PD. In today's video, we're going to start with a new topic called typecasting in Java. We have already seen what data type is and what are the types of data types, that is primitive and non-primitive data type. So in this typecasting, we'll see what typecasting is, then the two types of typecastings in Java, which is primitive casting and non-primitive casting. Then under primitive casting, we'll see what auto-widening is, then what explicit narrowing is, what is loss of data. Then we will also see what upcasting is and what downcasting is. So this is going to be a very wonderful video, and it is going to be super easy for all of you to understand. So let's start with typecasting definition. So it is converting one data type into another data type. And then there are two types of casting in Java. One is primitive casting and the other one is derived or non-primitive casting. Let's start with the primitive casting. Primitive casting is converting one primitive data type to another. Okay, now we know that there are different types of data types, like primitive data types, which are byte, short, int, long, float, double. So converting one primitive to another primitive data type could be either converting everything in the ascending order, that is either byte to short, short to int to long, or float, double, or int to double, or short to float, anything. Okay, that is a smaller primitive data type into larger. It could be anything. It could be byte to short also. It could be byte to int. It could be int to double. So converting smaller primitive data type into any of the bigger one is called as primitive data type. And this is done automatically by the compiler, and hence it is called as auto-widening. Why is it done automatically? We will look at it with one simple example. Now, for example, you have a glass of water and you have a bucket. Now, when you pour a glass of water into a bucket, there are no spills, nothing. It is just going to accept everything. All the water inside the glass, it is going to get accepted by the bucket. So it is just happening automatically. In the similar way, when a shorter one is converted to a bigger one, it is going to accept it because its memory allows it. Okay, so let's look at it with an example. Now we have a public class main, and we have a main method in that. We have int num is equal to 10. Now here, this 10 is the value which is stored in this variable called num, whose data type is int, okay, which is here. Now I want to convert this num into double, which is a bigger one. Okay, so what I'm doing is I'm going to store this num in another variable called d, whose data type is double. This is automatic conversion. It is going to happen, and when we print d, we're going to get some output. What output are we going to get? It is going to be 10.0 or 10.0. So here the int is converted to double. How do we understand this? Because of this decimal sign. Here no data is lost. Initially the value is 10 and now is 10.0, which is same. No casting syntax is needed. Casting syntax is the parenthesis, and hence it is called as implicit casting. Now let's see what explicit narrowing is. Okay. Now explicit narrowing is converting bigger primitive data type into a smaller one. Okay, one second. Yes. Okay. And converting bigger to smaller, and it should be explicitly specified by using the cast operator. Why I am saying this is, see, smaller to bigger, there's no issue, it can accommodate, but bigger to small, it is not easy to accommodate everything. Let's see an example. Now here we have a public class main, and we have a main method inside that. Now we have this double d 10.75, where this is the value stored in this variable d, whose data type is double. Now I want to convert this double into int. Okay, now so I'm just doing it as it is. So this is d, okay, and I want this to be of int type, and so I'm explicitly telling it to be of int using the cast operator, and I'm going to store it in a variable called num, whose data type is int. And now when I do a sysout num, I'm going to get some value, okay, and that value is going to be 10. Okay, so initially it was 10.75 or 75, I'm sorry, and now it is 10. What has happened is there is some loss of data. Okay, that is the part after the decimal point is removed, and hence we have data loss, and hence narrowing is risky. So this is how we have converted a double to int, that is a bigger primitive data type, into a smaller one. In the similar analogy, if we take the example of now a bucket of water, Okay, and if I try to pour it into the glass, some or more of the water is going to get spilled, and hence that explains the data loss. So this was about primitive casting, where we saw auto widening and we saw explicit narrowing. Now we're going to see derived casting or non-primitive casting and its types, which is upcasting and downcasting. So derived casting can happen if a child class object into parent class reference, or there is a parent class reference back to child class. This only works when there is a relationship, that is inheritance. Okay, currently this is not very easy to understand, so we will understand upcasting, downcasting and things, and we'll come back to this definition. So upcasting is converting an object of subclass to behave like any of the superclass. It is done automatically by the compiler, also called as auto upcasting. Okay, it says converting an object of subclass, that is converting an object of child to behave like its parent. Okay, and this is done automatically. Let's look at it with an example. So we have a class animal and we have a method in it void sound, which says animal makes sound. And we have another class dog which extends animal. So this is child parent relationship, that is inheritance. That is, there is a relationship which means that, for example, we have this animal class and we have a dog class and it inherits from animal. Okay, similarly, if there is another class, say tiger, it also inherits from animal. If say there's another class called cat, it inherits from animal. So dog is an animal, but all animals they are not dog, but yeah, dog is an animal, so all dogs are animals. So this is a relationship. Okay, let's understand that with upcasting. We have got this parent class, we have got this child class, where we have a child method void bark, and which says that's us out dog barks. Now we have a main method. Okay, and we have animal A is equal to new dog, which means that this dog object is stored in the animal reference, that is a child object is stored in the animal reference. If you see, that is a parent reference, that is a child object into parent reference. That was the definition. So child class object stored in the animal reference, and now when we try to access a.sound, it is going to run as animal makes sound. Here, this child class object now is behaving like a parent, and so it could access the parent method. And I'm saying it behaves like a parent because this now cannot access the bark method. So when you try to play a.bark, it is going to show an error. Okay, so this is a parent of reference and can only access parent method. That is, this child is now behaving like a parent, which is called as upcasting. Now let's look at the downcasting. So downcasting is converting an upcasted object to behave like subclass type, is called as downcasting. Now this upcasted object, we would like to behave it as child. That is, this child who was behaving like a parent, we wanted to behave it like a child now. So upcasted object should be explicitly specified in the program using cast operator for downcasting. Okay, so a simple meaning is converting parent reference back to child. In the above example, when we had this animal and dog class, where dog extends animal, and we have had a main method saying the new dog was stored in, that is a dog object was stored in the parent, that is an animal reference. So this is called as upcasting. Now I want this to behave like a child. Now this A, okay, should behave like a child. So this is dog, and I'm just storing it in the dog reference. Now this D could access the child methods, and obviously it could access the parent as well, because now this behaves like a child and child is extending parent. Okay, so here we explicitly cast using dog operator. Now we can access child methods along with the parent, and this works because the object originally was created as a dog. So this was all about typecasting. Now we will understand this with a simple code. First, we're going to understand the primitive casting. So here I'm creating a class named as primitive casting, and I will also take a widening method. Under primitive casting, we had two types. One is auto widening and one is explicit narrowing. We'll start with the auto widening. So auto widening is converting smaller primitive data types into larger primitive data types. Here I'm going to take an example of integer getting converted into double. So I'm having int data type. So int I is equal to 100. So this 100 is the value which is stored inside the variable I, whose data type is int. Now I'm going to put this I in another variable d, whose data type is double. So this is simply converting int data type into double. So when I sys out and I want to print I and I also want to print d. So when we run this, we get the value of I and d respectively. So the value of I is 100 because it is an integer value, and the value of d is 100.0. So this is converted to double. So this was an example of auto widening, which is converting smaller primitive data type into larger primitive data type. Now let's take a look at explicit narrowing. Explicit narrowing is converting larger primitive data type into a lower primitive data type. So here we are going to convert a double into an int. So double f is equal to say 100.75. Now this is a decimal value and I want to convert it into int. So for this I will require a cast operator. Let's see how. Now if I'm going to store this f in an int a, we are getting an error for this. Okay, I'm just trying to do similar what we did for auto widening, where I'm just storing the double f into int and we get an error and they say that we need to add a cast operator. So we're going to cast this. What is this? F. I'm going to cast this as int. Okay, so now if you see, the error is gone because of this cast operator. This cast operator will help us to convert the double to int. And now I'm going to do a sys out. Let's print f as well as let's print the value of a. The value of f is going to be 100.75. If you see that, because we have already declared it. And the value of a is going to be 100. This is only going to print the integer value that is before the decimal sign. So there is going to be a data loss. And so explicit narrowing is risky, as explained before. Okay, let me run this. You see that f is 100.75 and a is 100. So we have successfully converted decimal into int. This is what explicit narrowing was. Now this was about primitive casting. So let's take a look at derived casting. I'm creating a class called derived casting and taking a public static main method, void main method. So derived casting, there are two types. One is upcasting and one is downcasting. For derived casting, we need a parent-child relationship, which is an inheritance. So here I've created a class parent, which has a void disk method, and I'm going to print sys out saying this is parent disk method. Similarly, I'm going to have a class child, which is going to extend a class parent. So yes, class child extends parent. Inheritance is achieved by extends keyword. Here I'm going to have one child method, which is going to be void print, and again I'm going to print some statement. So sys out saying this is a child print method. Okay, we've got parent and we've got child, and now I have this derived casting class and I have a main method. Now let's try all the permutations and combinations, and in this permutation combinations I'll explain what upcasting and downcasting is. Okay, so first we are creating a parent object and I'm storing it in the parent reference. This is similar, a simple one, object of parent created. And now we'll see what this p1 can access. p1 dot, we can see it can access disk. So obviously because it is a parent object, it can only access parent method. Similarly, it obviously cannot access child method. Okay, let's see. Can you access? No, because even if it is inheritance, child is going to inherit methods from parent. So yeah, this is wrong. Now I'm going to create an object of child and store it in the child reference. So child C1 is equal to new child. Okay, new keyword. By this new keyword, we get to know that the object of child class is created. Okay, now this C1 can access C1.disk, which is a parent method, and it can also access C1.print, which is a child method. This C1 can access both because of inheritance, that is parent-child relationship. So it can access parent as well as child methods. The reason is inheritance. Okay. Until now, nothing has come where we could understand upcasting and downcasting. Now, let's have a parent reference, parent P2, and let's store a child object in it. So parent P2 is equal to new child. As per the definition of derived casting, a child object stored in the parent reference. You can see P2.disk. And let's see if P2.print, it is not available. Why? Because here, this new child, that's a child object, is behaving like a parent because we have stored the child object in the parent reference. So as child behaves like a parent, that is, it is upgraded. Hence, it is called as upcasting. Okay, upcasting, it is done automatically. It does not require any cast syntax. So it is also called as auto upcasting. And now let's also take this example where a child reference, we have child C2, and we are trying to create an object of parent. Okay, this cannot happen. A child reference cannot hold parent. This is an invalid, this is an error. This is a compile time error. And because child reference cannot hold a parent object. Okay, so this cannot happen. Now, let's take another example where this upcasted object, okay, we want it to be downcasted. We want it to behave like child. So this P2, which had a child object in the parent reference, this child was behaving like a parent. Now we want it to behave like a child. So this was upcasting, where a child was behaving like a parent. So I want this upcasted object to behave like a child, which is also called as downcasting. So child C2 is equal to, I'm going to use cast operator here because I want this P2 to behave like a child. Okay, this is a wrong syntax. Missing is the cast. So I've casted this P2 as child. Now this C2 can behave like a parent as well as child. I mean, it behaves like a child. It can access both parent and child's method. So C2.disk and C2.child. This is called as downcasting. Here, the upcasted, that is the P2, okay? Here, the upcasted object, it behaves like a child. Behaves like child. And behaves like a child, so it can access both child and parent's method because of inheritance. Okay, now when I run this, let's see what happens. See that? Okay, let me do one thing. Let me decorate this so it is easy for everyone to understand. I'm going to put some separators and then run. When I run this, if you see upcasting, this is a parent diff, that is the child can only access the parent, and downcasting, the upcasted can access both the parent and child's method. So this was about typecasting. Hope you enjoyed it, and please like, share and subscribe to my video. Thank you.